there is a formula created from a mathematician named Gauss. A German, by the way. Sorry for that.
Brunswick, by the way. Hello, here are the guys from Germany. My name is Thomas and my guest today is Achim. Good morning, Achim.
Good morning, Thomas. Hello, world.
Hello, world. So today is day 18 of Advent of Code. Can you explain us the riddle, please?
Yes, story-wise, we have to dig up a lagoon for storing a lot of lava, and we get a puzzle input similar to this, and it's told that we have a direction and a length that for a trench that we have to dig up, and this is told to be the color of the trench border in which it has to be painted, which is only important for the elves. And
so we can ignore the color in this moment.
Exactly. For part 1, we don't need it.
Okay.
And the example input builds up in the trench like this. And we also have to dig up the interior, and we have to determine how many fields are dug up. So the original trench plus the interior area. For part 1, I more or less did exactly that. So I put in the dig orders. I have here, my parser method. So I have the direction, I have the length, and I have the color, because I thought we would need that in that form for part 2. Spoiler, it wasn't.
Okay, after 18 days of puzzles, this parsing is not a problem. This is
not a problem. No, not really.
Not really.
Don't be confused that here's an empty part 2 method. I will throw it away because I did part 2 in a different class. So.
Good. After your parsing, what are you doing?
After the parsing, I have now 3 sets of integer. I have the trench, I have the supposed left area and supposed right area of my trench. Taking in consideration things that I did on day 10, where we also needed to calculate the interior of an area. And then I process those dig orders. As you can see here, I start at x100, y300. I have an offset here to avoid going into negative ranges.
Yeah.
And I more or less store each point that I have dug up and their neighbors into a set of integer, calculate and putting the coordinates in here in this format, so that I compress them into one integer. That's why I made sure not to be in the negative. And I more or less paint into the memory what I'm digging up. And when I'm done digging up, I'm filling the supposed interior. Or more or less, I fill the areas outside of this. Not very efficient. I tried to implement flood fill, but if you do it recursively, you get a Stack Overflow exception, because you're putting too many procedure stacks on the stack. So I did try to implement something similar iteratively, and I wanted to have a short implementation. So I built this fill method that I'm calling several times until it doesn't fill anything any longer. That's why I'm returning here a modified count. So I'm going through the entire supposed grid that I have to process. That's why I have minimum and maximum x and epsilon values. Go through that entire field, look onto each field that is a dot, so untouched ground, and then determine whether it's neighboring a field from the right or the left area, and paint it as such, thinking that this might be successful.
Okay.
And when I'm done filling, I'm going again over the entire grid and counting the left and the rights. For debug purposes, I put them out here, and somehow it's the right area that I'm interested in, and I add it to the trench size and have the result. However, that is not what I really should have implemented.
Okay.
Going over to part 2.
And what's the twist for part 2?
The twist for part 2 is the elves, as everywhere, as so often, have messed everything up. And the point is that the supposed directions and lengths that we were given for part 1 aren't directions and lengths that are seemingly somewhat color codes that actually don't interest us. Instead, the color codes aren't color codes. So the first 5 digits are the lengths in hexadecimal encoding, and the 6 digits of is the direction.
Okay.
0 means right, 1 means down, 2 means left, and 3 means up. And that way, the sample data now produces a result so huge, you just can't paint it in the memory anymore. That doesn't work at all.
Yeah, I got it.
So for the second part, I have a completely new implementation. I have a new class dig order that has only direction and length. Parsing, I look for the hash. The 5 following characters are the length and hexadecimal encoding. And the 6th character is a direction. And I go through the input, parse my dig orders, and from the dig orders, I calculate my trench pieces. Also, I have offset values here. I come to the reason for that is a little bit different than for part 1. From the dig orders, I calculate my trenches, and here's a debug output because I have to be at my start point again. And as you see at the comment, my offsets were originally 0, 0, 0, which is fine for the demo data, but probably not for my real data. So I can create my trenches. And in the constructor of the trench class, I have a switch case over the direction. So whether I go up, down, left, right. And my trench has 2 pairs of XY coordinates. And if I'm moving horizontally, so if I move left or right, the epsilons are the same. And when I move vertically, the x's are the same. And I had a little bit of a trouble finding the real thing to use, and considering the time I needed to ask Google the right question, this result is a little bit ashaming, but there is a formula created from a mathematician named Gauss, a German, by the way. Sorry for that.
Brunswick, by the way.
Yes, that's also. Who said if I have a polygon in the first with all its points lying in the first quadrant, then I can calculate through each edge by having the differences of the x coordinates, multiplying them with the sum of the y coordinates, and dividing that by 2, and summing these all up. I can simplify this a little bit here because if my x's are the same, that segment results to 0. And if my x's are not the same, the y's are the same. So it's sufficient to use it once, and thus omitting the div 2. And that's also why I have this offset here, to make sure that my polygon is completely in the first quadrant. So I have only positive coordinates.
Okay, this is the reason.
That's why I also have here some debug output to calculate the minimum and maximum x and y values. And then I had still some parts missing. And I determined that in addition to the area, I would also need some the trench length, but not all of it. I needed half the trench length plus 1 to get the right result for the test input. And that did also work for the real data.
Okay, does this also work for the first riddle, for the first part?
I didn't try yet, but I will.
Okay, Achim, thank you. What was this time the hardest thing for you, the hardest challenge?
In part 1, I had to rewrite my fill method because the method from day 10 wasn't fast enough. And in part 2, actually finding out that there is an existing formula that I can use, that there's no problem at all. Yeah.
Okay. And do you like this riddle?
Yes.
Nice. Okay. Then, Achim, big thank you to you. And then we see us tomorrow.
See you tomorrow.
Bye-bye.
Bye.